Hi friends, today my topic is related to welding. So the dimensions we are calculated, what is a weld bead dimension, and calculation of width of HAZ. How can you calculate width of HAZ as well as weld bead dimension. Friends, if you know what is a bead and welding symbol, so you watch my videos on YouTube. Already I have uploaded on this topic. So now we are talking about weld bit dimension and how you can calculate width of HAZ. So some assumptions are taken here. These assumptions are known as Rosenthal's critical assumptions, and these are four assumptions given here. The first one is energy input from the heat source is uniform and move with a constant velocity, that is a travel speed, also known as travel speed v, along the x-axis of a fixed rectangular coordinate system. Now the equation is given here. Efficiency of heat source equals to energy transferred to the workpiece which are welded divided by energy generated by heat source, that is neta equals to q divided by vi. V is the voltage, I equals to current, that is a capital V and capital I. And if you want to calculate net heat input, then small q equals to neta voltage multiply current divided by small v, that is a welding speed or travel speed. So this is the first assumptions you take here. This is a formula of this first assumptions. Now the second one is heat source is a point source. Notice here is a point source with all of the energy being deposited into the weld at a single point. This is the assumptions, second assumptions. Now the third one is thermal properties like conductivity, specific heat and density of the material being welded are constant, no change in thermal properties. And now the fourth one is modify the coordinate system from fixed system to the moving system. So this is the fourth assumptions, that is the assumptions is known as Rosenthal's assumptions. Friends, some points are noticed in mind for further equation solving. R equals to in square root x square plus y square plus z square, and alpha equals to k divided by rho c in meter per second. So what is the R? R is the distance from the heat source to a particular fixed point in meter. R is a heat distance from heat source. R is a distance from heat source to a particular point and taken in meter. Here friends, W equals to 2P. P is the penetrations. Okay. P is the penetration and W is the weld bead width. Weld bead width. W equals to 2P, because friends, for symmetrical weld it is a half of the width. For symmetrical, this penetration is a half of the weld bead width. So for this is a second assumption for symmetrical. So friends, you see this graph. This is a theoretical relationship between weld beads cross sectional geometry and the welding process operating conditions using two dimensionless parameter which is known as D and N. Dimensionless depth, width, depth and operating parameter N. So this is the two parameter relations, weld beads cross sectional geometry and the welding process operating conditions. So this is a D, y axis so D and x axis having N. Okay, and points are number points are given here. You see here, this is a little bit curvature, not straight but little bit it having curvature. So the weld depth D equals to penetration multiply travel speed divided by 2 alpha, and alpha is equals to thermal diffusivity meter square per second. So here P is the weld penetration, T is the room temperature. If your workpiece, welded workpiece is taking as room temperature, then you take T naught equals to room temperature. Otherwise, these terms are not used when if you having preheat your working piece. So the T naught is, you can say, temperature of workpiece at the start of the welding. Temperature of workpiece at the start of the welding. Okay, if your workpiece on room temperature, then you take room temperature. Otherwise, the temperature of workpiece at start of welding you take. It may be 40 degrees Celsius, 50 degrees Celsius after preheating. So these temperatures are taken here. And if you take room temperature, then room temperature are considered here. So Tm equals to melting point of workpiece, V is the welding speed, meter per second, alpha is equals to thermal diffusivity, and Ts equals to solidus temperature of workpiece. And this temperature is also known as temperature of some relevant phase transformation. This is also known as phase transformation temperature, or you can say phase transition temperature. Here terms are equally related. Solidus temperature, transition temperature, or phase transformation temperature are equals. So abbreviations are given here, you keep in mind, friends. So this is a width and this is a depth of penetration. If this is a symmetrical, then you use W equals to 2P. So now your formula will become N equals to Q welding speed, travel speed, V divided by 4 pi alpha S square rho C in simple bracket melting temperature minus T naught weld start temperature of workpiece. Alpha S equals to thermal diffusivity of the base metal in solid case. Okay, for the HAZ, heat affected zone, the formula will become same, but here it will be changed. Ts solidus temperature minus T naught will use only here. So this is a for HAZ solidus temperature here use, and this is a normal. So operating parameters N equals to these and N equals to this for HAZ. So thank you. I hope you enjoy this all videos on the welding. Thank you.